Hello to everybody for this new session, this new Zoom workshop organized by Shellac Instrument. Well, I'm François Cochard, I'm the boss of Shellac Instrument, and really it's a pleasure to see so many people online. I want first to thank Patrick Fricker, who will do the presentation. So he will do the presentation about his experience in remote spectroscopy. So we have understood that remote spectroscopy is something becoming very important for more and more people, and for sure this is the future of the astronomy. So this is very interesting, and in this area, Patrick is really one of the pioneers by his experience. So I will not talk on his behalf. He will do that much better. Um, well, we ask you to close the microphone as much as possible. And again, you can ask the question by chat and we can interrupt. We will read, Olivier and myself, the chat to ask questions. So thank you very, very much, Patrick. I give you the microphone, and well, we have already seen, we had already the same session in French a few days ago, so now I know that it is very, very interesting, and it's a pleasure to hear what you are presenting. Thank you, Patrick. I give you the microphone.
Hello, everyone. My name is Patrick Fricker. I'm 50 and I do live in Switzerland in the Alps at approximately 1,800 meters. And first of all, I would like to say thank you to Shellac, to François and Olivier for giving me the opportunity to show you my remote solution. A short disclaimer, my English is not my mother tongue. I will do my best. I hope to be understood. If there is any question, just ask. Feel free. This presentation is a personal return of my experience. I have no academic or institutional claims. I'm neither a researcher, nor an academic, nor a computer scientist. The work presented here is part of an amateur pro-am astronomy approach based on rigor, experimentation, and my experience sharing. The technical and software choice presented are context dependent and should not be considered as a universal recommendation. The results shown illustrate the capability of my system and the methodology without any claim to replace any professional scientific work. The scope of this presentation: I will show you my remote spectroscopy approach, the technical and architectural choice I've done, the observation automation I've programmed, developed, some scientific results, and at the end, a practical return of experience. It will not show any step-by-step tutorial or universal solutions, neither a detailed source code. Important as well, the spectral data reduction pipeline I use is intentionally out of the scope of this presentation and maybe one day be presented separately in a dedicated talk. What if I could observe the stars from an aircraft at 10,000 meters above the Atlantic Ocean? Why? I'm a former pilot, airline pilot of a major carrier in Switzerland. I've crossed the Atlantic Ocean many times a month. Out of the 12 hours of work, I was 8 hours at the command of the aircraft and 4 hours in the bed you see on the picture. And I've always thought I would love to watch the stars from this bed when I'm resting and waiting for the landing. And that's how this crazy idea, this crazy project I started. I launched Mountain Peak Stars Observatory in 2010. It's just a name. It's not an association. It's not a company. It's just a name I gave to my project. When I started the project, I started with clear requirement specifications, scientific objectives. I wanted to do low and high resolution spectroscopy. I wanted to do long-term pro-am programs like BESS, ARAS, AAVSO, and others. And I wanted to do regular and repeatable target monitoring. For the operational requirements, I wanted to have a European site with a remote operation. Very important, an on-site presence for light maintenance and the use of multiple instruments. Another requirement for safety, I wanted to have an autonomous safety procedures, which means without my intervention, the system should park and close the roof itself, and a fault tolerance and recovery after incidents, which means if the system crash during the night, the system should automatically recover to a certain point to save the instruments, basically to park the telescope and close the roof. As well, regarding the automation, I was looking for a fully autonomous system without any intervention from myself, as well an automated observation sequence. I was looking for a system which would choose the stars to observe automatic without me entering a list of stars every evening. And if any human intervention is required, is post-incident the next morning. I didn't want an alarm to ring during the night for me to do an intervention or to save any systems. Regarding data quality, I was looking for a clear, defined, systematic pipeline for the calibration process and a logging of operations and incidents, which means a logging system which show me after every day, after every night, which targets have been observed and if there were any incidents to have a clear report about the night. Last but not least, usability. I was looking for a system with a control interface, a web and mobile-based interface. Regarding the observing site, I chose an observing site in the southern of Spain with a seeing of mostly of the time below 2 arc seconds, and we have more or less 260 clear nights per year. Meanwhile, there are more than 100 hosted telescopes. It's a big site. We have individual roofs, 3 meter by 3 meter, with high-speed fiber connection, redundant power supply, and very important, an on-site technical support. As well, we have high-quality accommodations possibility, which means we can sleep on-site, very nicely done by the owners, and I do travel there 1 to 2 times per year just for maintenance, just most of the time just for cleaning. The setup, slightly too ambitious to be honest. I have 3 telescopes on 1 mount. I have a high resolution spectroscope on a Celestron C11 with a custom made motorization made by myself. In the middle, I have a Skywatcher Esprit 120 and a field wheel for astrophotography. And on the right, I have an RC10 with a Shellyak motorization. To be honest, I use 80% of the time I use my Celestron C11 and I do high resolution spectroscopy. I use the low resolution just few days a month and the APO 120 very rarely. That's why it's a bit too ambitious to use all three telescopes. There's so many things to discover just with one telescope. It takes all the time. Regarding the LHIRES spectroscope, I did with a 3D print, um, um, two motor system to motorize the grating and the collimation lens, and it works pretty well. Very important experience I've made are regarding the connectors. Um, the connectors are very, very fragile. I would strongly recommend to fix the cable tightly to avoid any flexion, traction, or micro movements, to use cable ties, for example, to make sure that the plug are not moving while using the system. That's why most of the contact issues are mechanical and not electronic. Another experience I've made is with the 12-volt plugs. They are nice, but there is a high risk of intermittent contact as well. Because, as for example, with this power box, inside the box, there is a small plate of metal which connects the negative pole of the plug. And if the metal plate bends due to pressure, then you might lose the contact. That's why I've designed with a 3D printer a piece of plastic to tie down the plugs that it doesn't move at all. Very important. I would strongly recommend a fixed cable is a reliable cable to avoid any flexion. Another point, very important if you have a remote system, is the network security. I've decided to have all the IT infrastructure computers. I have 4 small NUC computers, Windows systems. I have the mount, I have a network access server as well. And I decided to hide them behind a router and a firewall. Very important. And the only way I can access from the left side, that's where it's here in Switzerland in my apartment. The only way to connect to the infrastructure in Spain is over an VPN tunnel to make sure that the IT infrastructure of Spain is not exposed to the internet. Very important. No equipment should ever be directly exposed to the internet, and all systems must be protected behind a router and a firewall. Next, important are the redundancy. They are very important redundancy. For example, the UPS. Of course, we have stable, very good 230 volts power connection, but sometimes we have power spikes or power cuts. And to avoid any damage to the infrastructure or any cut during the night, I would strongly recommend a UPS. And basically, there are 2 types of UPS. They are a so-called line interactive UPS, which has a commutation time of 2 to 4 milliseconds, which means with this type of UPS, the infrastructure is powered by the power line. And if there is a cut, the UPS switch to the battery, but you have a cut of 2 to 4 milliseconds, which might be too long and might cut the power to the mount or to the computers. That's why I would recommend a bit more expensive, an online type UPS, which means the power connection, the power line, powers a battery, and the battery powers the infrastructure, which means if there is a power cut, there is no break. It's a completely stable voltage and a full protection. I would strongly recommend an online version. As I said, is a critical component and not just an accessory to have. Another important redundancy is the internet connection. We do have a good and stable fiber connection on site, but we have cut as well. That's why I would recommend a backup system, either with a mobile 4G or 5G connection or over a satellite. For my setup, I choose to have the satellite version as the primary connection and the land, the fiber solution on site as a second, as the backup solution. And this works perfectly. For instance, if your system depends on internet and you don't choose a redundancy, then the system must be able to operate safely and secure, and it secure itself automatically. That's very important. You should not depend on the internet connection. The system should stop, for instance, as the plate solving solution with astronomy.net. If you have no connection to the internet, the system should trigger this, park the telescope and close the roof securely. This is very important. Another redundancy, which is I would strongly advise, is a so-called KVM over IP. I choose, as I said just before, the solution of 4 NUC computers and have Windows on it. And from time to time, the Windows needs to reboot for Windows updates or for any other reason. And if the system reboot and you have a screen which asks you an click with the mouse to confirm an option, but you have TeamViewer or AnyDesk not running, then the boot sequence stuck and stop. And you need to plug a mouse, a screen, and a keyboard locally on the computer to continue. And this is not possible if you have a remote system. That's why I would strongly recommend a KVM over IP. It's just a box, and you connect a cable, a screen cable, a keyboard cable, and a mouse cable to this box, and you can access low level over a web browser to the BIOS or to the boot sequence. This is very, very important, which means the KVM over IP allows recovery when the OS is not responding or if the boot sequence is stuck. Otherwise, you have to unplug, you need local help, and to avoid this, I would recommend this solution. Another redundancy, which is very important, is the data storage. I choose to have my raw data on a redundant storage system on site, and I do the data processing and the analysis at home here in Switzerland. And for this, I choose a mirrored NAS solution, which means I have a NAS locally in Spain, I have a NAS local here in Switzerland, and every time a file is saved on the NAS, it's mirrored here. If I lose data locally, I have instantly a copy here. I've made a bad experience in Spain because of the temperatures. During the summertime, we easily have in the observatory temperature high as 35 degrees centigrade or even 40 degrees centigrade. And the hard disk with this temperature, that's a big problem, big issue. I broke 2 hard disks just because of the temperature. That's why it's important as well during the day to shut down every system to make sure that they are protected from the heat. Because we do not have climatization, we do not have any ventilation system. That's why it's very important to not to lose your data. And with a RAID system, you can lose 1 hard disk and the system is still running. That's important as well, not to rely only on 1 hard disk. For the software, I choose to do the automation of the observatory myself with Python scripts. The acquisition, I use CCDCL from Patrick Chevalet. Very, very nice piece of software with a very good support. I'm more than happy with this. It's completely controlled by Python scripts. And I do not use the GUI as the user interface. I only trigger and control with Python scripts very well. It's working very good. The processing, I use SpecInT, Visual Spec, and as well my own Python scripts. With the results, I use Python scripts to create graphs and to analyze the information, to publish the results on BESS, ARAS, AAV, and so, and to other people. Regarding few challenges I would like to share with you. As I said, for my high resolution telescope, I have a C11 with a focal length of approximately 2300 millimeters. And the field of view of the guiding camera is very, very small, very tiny small, which means I have issues to do a plate solving, which means it's very hard to center the star on the slit. And for this, I choose a solution with pointing, with a small pointing scope attached on the C11. And we can see on the left an orange-brown rectangle, which is the field of view of my guiding camera. The picture, the whole picture is the picture from the pointing scope, and the green dots are the center of the slit depending on the position of the telescope, which means I have quite a big flexion, maybe due to the fact that the pointing scope is attached to the C11, but as well a bending due to the weight of the spectroscope on the back of the focuser. Which means I cannot just do a plate solving and center the stars. I have to take into account the position of the telescope. If it's pointing upwards to the zenith or to the horizon, and you see the red square, they are the center of the slit when I do point to the west, and the green when I do point to the east. And what I've done, I've programmed with Python a model depending on the position of the telescope to make sure that I do a plate solving correctly on the given pixel to make sure that the star is centered on the slit. Which means careful, pay close attention to flexures with such a big focal length. Another challenge I had is regarding the back focus and autofocus. I choose to block the primary mirror of the C11. And I have an external motorized focuser in the back. But the problem is that I have to adapt or to change the position of the external focuser depending on the temperature. And the travel of this motorized focuser is just enough to compensate the temperature changes between summertime, when it's 30 degrees centigrade in the middle of the night, and now in the winter with 0 degrees. I would strongly recommend to pay attention to the travel of the focuser depending on the temperature. And what I did, I programmed a script to calculate the smallest FWHM of the spectrum to make sure that my spectrum is sharp. I do record the position of the focuser and the temperature, and I do create a line, a curve, which is visible on the right-hand side of the slide. And I'm pretty accurate with these points, which means today I can point to a star, take into account the temperature. With this linear fit, I have according the position of the focuser, and I'm pretty close to a sharp spectrum. Very important. But important is that the back focus is correct. You cannot correct a wrong back focus with an autofocus. Now, there are, from my point of view, there are two philosophies regarding remote. There is a remote supervised, which means you sit in front of your computer. Your remote telescope can be in Spain, like for me, or in your garden, just connected with a cable, is remote as well. If you have it supervised, which means you stay in front of your computer, you have the big advantage of flexibility. You can always interact and safely park the telescope if there's any issue. You can debug if there's a problem with the software. This is very, very good, but it's very time consuming. You have to spend the whole night in front of your computer sitting and taking pictures, taking spectrum. The other solution is an unsupervised solution, which means it's fully automatic. The big advantage is you can sleep, but it's complex because you have to program, you have to develop a software or a system which is completely autonomous. And this is risky and, of course, rigid because you are not sitting in front of the computer. But that's the solution I was looking for. Regarding the architecture I developed, I don't want to go too deep into the system, but high level, you see with right rectangle on the top, all the devices connected to the system, like the roof, the cloud watcher, the mount, CCD motors, and so on and so on. To communicate with these devices, I developed interfaces. Like for the roof use a serial connection. Like the cloud watcher is a file on disk I have to analyze. Or like the mount, we can talk over a WebSocket. After developing these interfaces, I developed a second level, that's the orange part, I do on every 2 seconds, 2 to 5 seconds, I do request the status of all the devices, and I store this information in a database table to have the latest status of the roof. Is the roof open or closed? Is the mount powered? Is the mount parked? Are the motors running? The position of the motors, and so on and so on. Which means I have a table with the actual status of all devices. In the middle, I have the safety conditions. The safety conditions could be, is it safe to move the mount? And these safety conditions ask the status of the devices if it's safe to move the mount. For example, is the roof open? Yes. Is the mount powered? Yes. Then it is safe to move the mount. And on the right hand side, you see the commands, which means move the mount to point Vega. And the command, based on the safety conditions, go to the interfaces to execute, to send a command to the mount to go to Vega. This is basically the infrastructure I've developed. On the right hand side, you see a solution I've developed to fetch lists. There are quite a lot of lists online with targets, with stars. And what I do on a regular basis, every day, I do read the list and I put the information in my database. You see at the bottom of the screen, a scheduler basically is a small table when the roof should open and close, when should the camera cool down or heat up again. And on the right hand side, I have a sequencer. And the sequencer is basically a list of the stars which should be observed during the night. And last but not least, I have programmed as well web services to front end to access to the database. For example, I've developed a dashboard where all the information, all the status of the observatory are visible. I use this screen to debug my developments. To be honest, today I'm not using it anymore because it's up and running, and I rarely use this. But on this screen you can see the weather, you can see the webcam, all-sky camera. On the right hand side you see the status of the UPS, if it's running online on the battery or if it's from the power line. You see the VPN connection and so on and so on. You have all information visible on one screen. What I developed as well is a web application, mobile application, for me to have the same information and as well to command the observatory with a mobile phone. While I'm working during the night, I can intervene, I can access the observatory. Here you have the same information like temperatures of the camera, focuser position, and so on and so on. The targets. I'm sure most of you know this table is the BES or the BE star from the BES website, aras.bes.free.fr, and you see all the stars, BE stars, which should be observed. And I just want to say one example. You see 10 Cassiopeia, you see the coordinates, and you see, for example, in the database, there are 63 total spectrum. Within the last year, 2, and within the last month, 0. And you see in green the date of the latest spectrum 22 November 2024, for example. And they would like to have one spectrum every year, 365 days. Or for example, at the bottom, you see another star, V594 Cassiopeia. They would like to have one spectrum every week. And the last spectrum in the database is from the 7th September 24. And you see very nicely in one go which stars should be observed. Next. What I do, as I said before, I do import this list every day. And you see on this picture, on this image, the last two columns of the table. The second last are the amount of spectrum, the number of spectrum I sent to the database, like the first row 6. And on the right, you see the date of the last observation of me, like 24 December 24, which means I can see with this table when I sent the last spectrum to the database. In red means that somebody else sent a spectrum to the database after me. And in green are my spectrum, the latest of the database. And in one go, I can see the situation. But important is now how to sequence the stars automatically. If you see on the graph, on the sky map on the right-hand side, you see all the green dots are BE stars. How to choose, how to sequence, which one to choose. There are 1035 BE stars. To be honest, at the beginning, I did this manually. I took a piece of paper, I looked which one are over 30 degrees, which one are visible more than 30 minutes, and did this manually. But I wanted to have this automatic. And what I decided, I defined parameters per target. The assigned spectrograph, would I like to have low resolution or high resolution spectrum? The spectral domain, H alpha or helium. The exposure time, basically based on the magnitude. Most of the stars have a total exposure time of 30 minutes. I defined as well a priority level from 1 to 3. By default is number 2. And a must observe flag, which means if I want a BE stars to be observed under any circumstances, I can flag must observe. But the targets are prioritized using a multi-parameter score I defined. And these are, for example, with the priority parameter, if the priority 1 is assigned, it will have a score, is just a number of 0.67. If the priority is number 2, the score will be 0.33. And if the priority assigned is number 3, the score is 0. The score is just a number to sort at the end to prioritize the targets. The second parameter is the urgency parameter. Urgency reflects the need to observe a target at a given time. For example, if they wish to have a star observed one time every 7 days, but the last observation is 9 days ago, it will have a score of 0.61, which means, yeah, it should be observed soon. If the observation span is 1 day, they would like to have one spectrum every day, but the last observation is 10 days ago, then it will have the maximum score of 1, and so on and so on. A third parameter I do take into account, I do consider, is the altitude. The higher the target is above the horizon, respective to its maximum altitude at the meridian, the better the score is. For example, if I take a star at 49 degrees altitude right now, but its maximum altitude is 82, it will have a ratio of 0.59 with a score of 0.40, which means I can wait until the stars continue to rise up. Another example, if the star is at an altitude of more or less 34 degrees, and that is its maximum altitude, which means it's very close to the meridian, and then I will take these stars into account and put the score of 1 with the biggest priority. And at the end, the final score to sort the list is based on the priority, on the urgency, the altitude, and the moon distance. This creates the final score. And I do calculate this score for right now and in 45 minutes. If the score improves, then I can wait. And I can wait for this star and take another star into account, which scores slightly improve or decrease. And 45 minutes later, I can reconsider every star, calculate the score, and optimize the automatic selection of the targets over the night. Good night. Now it's the automation. It's time to go to bed. The system is up and running. I checked the system with my mobile phone. I crossed the fingers and I hope everything is fine. The following morning, I need tools to review the night because I don't know the stars the system will select. I have no idea. And I would like to have a review about the quality of the nights. And for this, I use the all-sky camera. I've created a model on the pictures to show, like on the left-hand side, the circle is my target with the number next to it, which is the exposure. And I see during the exposure number 3, there were clouds. Maybe it would worth it to look at exposure number 3 to see the quality of the results. Maybe I can decide if I want to use this exposure for the final processing or if it's okay to continue with it. On the right hand side, you see a beautiful clear sky, no clouds, easy. I can continue with all exposures. Very quickly, I see if there's any problem regarding the cloud coverage. Another review I do get automatically is about environmental conditions. For example, wind. I see on this graph vertically every exposures, and I see that at the beginning, let's say I have 5 to 6 exposures with quite a lot of wind of 5 kilometers per hour. Maybe I should have a closer look to the guiding graph to make sure I will not have a problem with the guiding. And very quickly, I can take a look about the quality of all exposures over the night. Next, the auto guiding is the usual presentation we have about auto guiding. I can see based on the CCDCL logged data, I do create this graph. And I can easily see if there are auto guiding tracking problems. Another very important part is the signal distribution. How sharp is my spectrum? And for this, I've created a script. You see on the left-hand side, the blue line, which doesn't look very symmetric. It's look weird. And the reason for this, you see on the picture at the bottom, it's because the telescope is not sharp. The picture is not sharp. I should have put more effort into the autofocus. And then I can decide if I want to redo the stars the next night or if I can accept the result. But this shape of the spectrum is clearly a sign of an unsharp focusing. In the middle, you see it's symmetric, but it's quite wide. If you see the vertical lines, which is the optimum FWHM of the spectrum, and on the right-hand side, you see the blue line is exactly at the position of the vertical lines, which is very, very sharp picture. And the system produces automatically these pictures, these graphs, and I can decide if I want to take into account, if I want to consider or reject these exposures. Very useful presentation of the sharpness of the pictures. Some results. Regarding the BESS campaign, in 1 year, I've produced 135 spectra of 83 targets, which means the system is working pretty well. And you see on the right-hand side, very nicely, it's moving. I mean, it's not just a spectrum which stays the same throughout the year, but it's moving, it's dynamic. It's really interesting to see changes with the beautiful tool of Visual Spec. You can compare your spectrum with spectrum which are already in the database, and you can see differences. It's dynamic, really nice. Another campaign I took part of was the campaign of Manfred Schwarz and Ernst Pollmann regarding VVCFA, and my contribution was 64 spectra to this campaign. And you see on the graph, every dot represents a spectrum of an amateur, and the red dots are mine. And it's very nice. It's very grateful to see your result when you compare with the colleagues. And that's the power of campaign when you work together with other amateur. It's motivating. It's motivating to see what you produce. You are not just putting information in the database, but you can compare with colleagues. Another one, which is basically my first campaign, was SS433, which is a binary system. And it was done with an Alpine, was my first campaign. Every line represents a spectrum. And this shows the power of a remote system because it's running night after night. And I was observing this binary system for more than 1 month. And it's a bit difficult to see on the screen, but you see blue points and red points, which means which are emission lines, small emission lines of the jets of the system. And this system is turning, has a precession, and you can visualize easily the rotation of the jets of this most probably black hole just by observing night after night the same system. It's very nice thing, very nice campaign to do. Another one was SS Cygni. I didn't know what to expect. I didn't know the system. I took my Alpine, and within 1 week, almost every night, I did a spectrum. And you see the emission lines uh, classic for this type of star. And then suddenly, in the middle of the graph, you see that the emission line disappears completely. And I thought, I've done something wrong. And the night after, you see the emission lines, they reappear. I didn't know exactly what it is. And then I had the idea, what about the colleagues with photometry data? And I used the results on the AAVSO database to plot the apparent magnitude next to my spectrum. And it's very nice to see when the event happened, when the emission lines disappeared, the magnitude rised about 3 magnitude. It's nice to see this, to see that there is a correlation between the magnitude and the emission lines. The last campaign was Play 1, the Periastron, end of October this year. I took almost every night a picture. I did a spectrum. I overlaid all the spectrum to see what happened. And here we can easily see on the top graph that the main emission line didn't move, didn't change over the time, over 2 months of observation. The changes are only at the top of the 2 emission peaks, 2 emission lines. And to understand that the big emission line comes from the inner part of the creation disk around Play 1. And the 2 peaks are from the outer part of the disk. The part which is coming towards us is the one on the left, and the part of the disk which goes away is on the right. And by overlaying the spectrum, you can see the dynamic. Even if you compare, if you show the information next to each other, you see how the intensity of the peaks, mostly of the red emission line, changes over the days. It's fascinating to understand. There are a lot of information, there are a lot of scientific paper online to explain this phenomenon. And just with equipment, a remote equipment which you can use every night, night after night, if it is far away in Spain, in Chile, or in front of your garden, to see the dynamic of a companion star disturbing a disk when it's passing by. Very, very, very rewarding to see this. Two books, very important books. I learned a lot. I do think there are English version, if not now, soon. The one is on the left. I learned a lot about spectroscopy, the basic of spectroscopy, the different type of spectroscopes. And the book on the right is a very nice book about 10 experiences, very nicely described, with example, with Python code, with beautiful pictures. Very good books. Perspective. Where do I want to go? I would like to create a platform for sharing spectroscopy experience. All the campaigns I've mentioned, I was basically alone. I was basically sending my data on the internet, on the web. But it would be so great to have a platform where we could all contribute, put our own spectrum to share, to compare, to learn. That would be really great. That's what I would like to work on without any academic pretension, just to enjoy and sharing experience. Sharing experience is as important as producing data. With sharing experience, we can learn. Limitations and point of attention. Today, I do trigger the system manually. The system is not able to evaluate the quality of the night at the moment. I do decide in the evening, okay, it's worth it to observe, go. But that's all what I do. The system is autonomous beyond that. Of course, is a strong dependency on software robustness. If I'm not programming correct, then I will have bugs, clearly. What is important as well is it needs a continuous maintenance. I always have to improve, to debug, etc., etc. An automation reduces operational load but increase requirements and complexity. This is important. As well, lesson learned. If I would start again, I would focus on one telescope. With 3 telescopes, it's way too complex. I would simplify software workflows I do. I did a big thing, but it's way too complicated. I'm sure I could simplify a lot of things as well. The test. Of course, I cannot simulate all degraded conditions. Would be nice to have a clear test system to make sure it works under any case. And the bottleneck I have now are the data processing. At the morning, I have 15 folders with all the pictures, and the data processing is still done manually by myself. I'm working on this now to optimize this and to reduce the workload. Unsupervised remote operation is built iteratively. It's very difficult to build from scratch with all the system, with all the logic behind. The system has been built step by step, system by system. Who is this type of remote setup for? This type of remote system is for long-term scientific projects, is for regular and repeatable observations, but as well for persons who are interested in automation and programming. Why? Because unsupervised remote system is not yet a turnkey solution. Conclusion, after all this, what I've learned, automation is not delegating, is anticipating. To anticipate all the cases, all the problems could happen because I'm sleeping and the system should be autonomous working. Thank you for your attention.
Thank you so much, Patrick. Wonderful presentation. Thank you very much. We have a few questions in the chat, and I think interesting questions. The first one is, does the British Astronomy Association, so the BAA, they have a spectroscopy section to share the data? And so I think that, yes, that's right. So you can send your spectra to the BAA database. But I think if I'm right, Patrick, when you are talking about sharing organizing campaigns like that. This is really sharing data and then playing with the data, working on the analysis of the data. And then I'm not sure what the BAA animators are doing. So I know that we have some members of the BAA online. I've seen that David Boyd is online. Maybe you can talk a little bit about that. And of course, Patrick, you can also
Yeah. Yeah, um,
comment.
yeah, exactly. You completely understood what was my intention. I would really love to not only to have a place with all the spectrum, but with play with it, to understand what is shown, what is visible, and why not having an access to an astronomer to explain us what is visible, to understand what we have on our spectrum. That would be really nice, and I'm sure there are astrophysicists to help us to explain us what we see on this spectrum, to create a dynamic, to let people contribute to one objective we would set together, we would define together. That would be really great.
Maybe I add a small comment. You said several times that you are not an academic guy and you don't want to replace any professional work and so on. So of course I understand the disclaimer, but you know that we can also work with a professional and ask them to help us understanding what happens in the sky. Something which is important is we don't have only to when I'm saying we amateurs don't only have to produce data and send them to the professionals. So I totally agree with you, Patrick. So we have to play with our own data. But in this part, I can tell you that most of professionals are very happy to help us to work with and to play with the data, and they can help us to better understand what happens there.
It would be really nice just to close the circle, not only to
Exactly.
produce, but to have the result. What do they do with our graphs? What do they analyze? What do they understand with our data? That would be really great. Yeah.
So maybe I don't know if somebody from the BAA is able to add some comment here on how they work with the BAA database. No? One, two, three. Okay, so we continue. I see in the comments also well there is I've seen a question about do you manage a way to prevent to switch from one side of the meridian to the other? Well, I don't see where is the question about,
Okay.
but do you take care of that? So
Yeah.
yeah.
Yes, exactly. I do take care of this. I do to calculate the score, to create the list of stars.
Mhm.
I do only take into account one hemisphere, either the west or the east, because I do not do a meridian flip. I
Okay.
tried to avoid a meridian flip. If a star is too close to the meridian to have 6 exposures, to have 30 minutes of exposures, I wait until the stars pass the meridian to do this target. Yeah, I'm not observing over a transit, over a meridian flip. Yes.
Okay. So we also had some comments about the two books. So the one from Olivier Gard and mine. So mine is already translated and I confirm, and Olivier is currently working on the translation. So I don't know, Olivier, if you know when it will be available, but I know it's on the way.
I am now in the proofreading solution with seven other astronomers from all over the world. So I think I can give the UK manuscript to the editor in January to 2026 at the beginning. So maybe you can have this book, let's say, 3 months after, in March, maybe, or April.
Cool. We have another question from Gary Bertolini. With regard to the automated alignment of the slits to the plate scope, you use the Python script. Do you interface to which guidance software, PhD2 or your own custom software controller?
Yeah, the auto-guiding process is done by CCDCL. I use the internal auto-guiding procedure of CCDCL. Yeah.
And then you can interface with the CCDCL, so you can
Exactly.
control it through your Python script.
Yeah,
Okay.
exactly.
Wonderful. Well, if any other people wants to take the microphone, so I see that there is
Yeah. Francois,
yes.
hello, how are you? Jack.
Hello.
I just want to go back to Patrick's question about the British Astronomical Association database.
Yes.
I'm a BAA member. Thank you for a fantastic presentation, Patrick. I have some similar setup to you in ideas. But to go back to your question about the BAA, it's a data mine of spectra. So people such as myself post the finished spectra onto the database, and it's what's known as a data mine. It's held there for anybody, a professional astronomer or you or me or whoever, to access for future reference. That's what it's there for.
Okay.
I hope that answers your question. Thank you.
Okay, thank you.
Thank you.
And well, so there is the BAA database, and there is also the AAVSO database. I think I've seen something about, yes. There is also the AVSO database, not only for photometry, but now also for spectroscopy. And there is also a post from Wayne Green talking about the SIS, so the Society for Astronomical Science. And so you have also, this is a good way to share data and experiences. Maybe, Wayne, if you are on, you can tell us a little more.
Yeah, hi. Just things here a little bit. Yeah, the Society for Astronomical Sciences is a group, almost like an anarchistic group of amateurs that get together every year, and we discuss among ourselves the problems and such that we have, ideas going forward. We spin out loose collaborations that do not work under our quote banner, but there again, our job is to put on the party. Your job is to make something of it. So we do have a weekly meetup where people can bring their spectra. Jack Martin often attends these things, as do several other people here, to put your spectra up and discuss it and get feedback and the experiences of the group. A lot of the experiences are bordering on a professional level, it just particularly in terms of the techniques of observations and such. And we do have access to professionals in the community that we can call upon from time to time. To help assist us with that kind of thing. So if you're really interested in that, you can feel free to contact either myself or I think Bob Buchheim's floating around here somewhere about the details of that. Excellent presentation, by the way, very excellent.
Thank you.
Yeah, Patrick, is there any reason why we here tonight, group of people, can't start our own group? Yeah.
Very nice.
By the way, we a few days ago we also had some intervention from Christian Brill talking about the Staros group, which is also another group where we want to share data experiences, manage campaigns of the observing campaigns, and so on. So it means that's interesting because it means we have several, if not a lot of databases and way to share data and share experiences. Now well, that's fun. That's fun enough. And my feeling is that all depends on people. So we having a database is something important because it means that technically speaking, we have a database where to send our data. But the most important behind is the humans and the motivation, the own motivation of few people just to do organize that. And I think, Patrick, that you're very good in a very good place to manage this kind of observation and campaign. Whatever the technical organization you want to do that.
Francois, I have a grandfathered account with Groups.io, which I can put up subsections. There's 2 or 3 running there now. Make that source available to you here. And our 2 most powerful tools are that in a general sense, which is an emailer list that can fire back and forth, and Zoom. A small group of us are currently doing an observing campaign in Chile. We get together on an ad hoc basis. Matter of fact, it may be a quick phone call between us. Hey, quick, jump into Zoom and take a look at this. So those are the kinds of collaborations that a loose confederation can really support. And I'm happy to help work with that.
Well, so I'm sorry, I don't know if the connection problem is on my side or on yours, but I didn't hear all what you said. Can you repeat, please?
Yeah, okay. Groups.io.org is I have a subgroup capability there. We can add a subgroup and you guys can have an email list, etc. And then there's another aspect of that is just the ad hoc, random, on the spur of the moment communications with Zoom. Quick email, jump into a Zoom meeting and answer questions really quick about things. I think the speed of feedback sometimes is important, and particularly if you're trying to bring up a remote system. Several of our people do remote observing, and we have remote systems and experiences. That's why I was incredibly impressed by the presentation.
Thank you.
So feel free to contact me. You got my email address.
Very good. Thank you. Yeah.
Okay. Thank you, Patrick.
Well, maybe I missed something. Well, we have the same question as a few days ago, Patrick. Is your code available to GitHub or something like that?
No, it is not available at the moment. I should, I know, but
Yeah.
at the moment
Is it because you don't want to share your code?
No. It's not because I don't
I'm
want.
kidding.
It's because maybe because I'm shy to share my code. Now I think it would be a great idea to share and to contribute not only on the spectrum but on the code as well, because there is a lot to do, and it's amazing what we can do as a group, and yeah, I would think about it.
Well, again, I do have some connection issues, so maybe it's only on my side.
We have, I think John have put his hand on, so you can ask your question, of course.
Thank you. I just wanted, my question was for Wayne Green. What is the name of your microphone is way up there? What is the name of your group on groups.io?
Any name you want.
No, I own and moderate a dozen groups. I was wondering, you have one specifically for spectroscopy now?
We have a group. To be perfectly honest with you, I turned it over to somebody else to use for quite a while. Let me put a pin in it. I'll get back to you in about a moment. Okay.
Thank you.
There is Gary also, who is.
Thank you, Francois. Someone also mentioned a question I saw in the chat regarding a further description of the modifications that you did to your spectroscope. I believe you said, Patrick, that you had added a motor, and I'm guessing it was to the grading so that you could select different wavelengths. Could you discuss that a bit, if that's correct?
That is correct, exactly. I've motorized the grating to select the wavelength, and I have a second motor to turn the collimation, the lens to adjust the sharpness of the calibration lines. Yes, I have two motors on it, and it's all done by 3D print. 3D print system. It's very easily to do. And it's working. I'm happy.
Very amazing. I'm curious how much time you spent on this automation. It just blows my mind. Oh, and also I understand why you don't want to put the software up, probably because you don't want to maintain it for other people, right?
Well, that, as I said before, that's the reason why I changed my job. I'm not flying anymore. I'm driving trains. I have more times to do this now.
Is the grating motor belt driven, Patrick?
Yes, exactly.
Yeah. Do you not have to be a bit careful not to over tension the micrometer because it could wear out the micrometer shaft?
Yeah. Basically, I'm not turning the micrometer shaft. I'm turning a cylinder around it. There's no pressure on the shaft. I'm turning a cylinder
Yeah.
to let the free movement up and down of the shaft.
Yeah.
Because it's exactly what I wanted to avoid. I didn't want to put a belt on the shaft because of tension, because of pressure. Yeah.
Okay. Because I have a LHIRES as well. So.
Oh, cool. Nice. Yeah.
Motorized collimation, but not micrometer.
Okay. Oh, we could share
Yeah.
how we solved this
Yeah.
issue.
Francois has my email
Oh,
address.
cool. Nice.
Yeah.
Yeah.
Absolutely. I see a question also a proposal having a Sheliak only forum and database would keep the equipment discussion right onto your product, so the discussion would be on the data. And there are some comments behind. I think that I don't maybe I'm wrong, but I don't really want to have a Sheliak forum only for this kind of discussion. I think it's better if it is open to everybody on any distribution line. So it can be the Spectro L distribution list. It can be on the AVSO on the different forums. So I think it's good to have something. Public and all what we are saying is. So of course there is a lot of Sheliak spectroscopes in the world, but I don't want to limit the discussion to Sheliak. Well, don't hesitate to comment if you want. But okay, so I see that Wayne has found the link to the group. Wonderful.
It's embarrassing. I forgot the name of the group.
Yeah, yeah, no problem. And well, are your 3D printer designs available? So this is a question for you.
Yeah. Yeah, could share. They're not available now, but we can we can
They are on the GitHub.
exactly. No, but we can exchange emails and yeah. Yeah.
Patrick, it's capable on GitHub to create what's known as a private account so that only people that you ask to be collaborators can come in and work with your code.
That's a good solution, yeah. I would think about this. Very nice.
Give me a
Thank
chat.
you.
We'll call, offline, send me an email and we can open something up.
Yeah, very nice. Good idea.
Yes, and if you don't have the addresses, I do have the addresses of everybody, so I can share.
Yeah, I can make that happen too.
Okay. So I think we were almost done. Any other questions or any comments? Olivier, on your side?
I have not seen any more questions, so maybe we can close this discussion. Or
Okay, so thank you very, very, very much again, Patrick. You did a wonderful job by making your instrument working and also by preparing the presentation that you gave us. So thank you very much. Congratulations.
Thank you.
And then we'll continue from time to time to have a workshop like that to share this passion and we want to push these automatic observations because I'm sure that this is what will change the science in coming years or decades. So it's just a wonderful adventure. Thank you. You are pioneer, and we continue. I wish you a very good break for Christmas. I hope that you'll have one, and see you soon.
Thank you, Francois,
Thank
for
you.
hosting this. Yes.